exact same notes. Last year probably didn't. All right, so we're going to simplify, multiply. Well, we're not dividing yet, even though I put that in the thing, but adding and subtracting real and imaginary radicals. Okay, so let's talk about the pieces of it because vocabulary can be important sometimes. When you have a square root, okay, what's inside is called the radicand. This thing is the radical sign. That's why we call them radicals. It can also be called the square root sign. And then the number that goes right here, or the number that doesn't go there if it's a square root, this is called the index, which is also just the root. Okay. But if you because again, when you get into college, sometimes the professor's up there teaching you like we're teaching you. Sometimes you have to read it from a textbook that they wrote, and then you have to know what all the words mean. So indices is plural for index, but the index is 3 when it's a cube root. It's 2 when it's a square root, that sort of thing. So what we already know, and we've talked a little bit already about simplifying square roots, you can do the same type of thing for any root, whether it's the cube root, the fourth root, whatever. But when we're talking about variables in here, so you must have 2 of the same number or a variable to take the square root. A perfect square for variables is when the exponent is divisible by 2. Okay? So I'm going to talk you through what we do depending on what our different indices are. So let's start with a square root. Okay, so we're going to simplify this thing, and let's talk about what we know and what we can figure out here. Okay, so I'm going to put equals, and I'm going to kind of put a skeleton for my answer right here and put some work down here. Here's what I mean by a skeleton. I'm assuming that I'm going to be taking something out of the square root, and most likely something will be left in the square root. If it's not, that's okay, we can rewrite it, but I'm going to leave me some space, and then I'm going to have a square root. That way I can kind of place things in there as I figure them out. Does that make sense to you? If this is a square root and I have a negative, what do I know is going to be in my answer? I. So I can go ahead and take care of the I, because it would come after everything else and right before the square. I'm just going to put him there. So I've taken care of that part. Then I'm going to look at the 24. Okay? So the 24, not a perfect square, so I'm going to do the tree. And when I started working this one out, I was like, okay, I'm going to talk to them about, the little shortcut you can take. And then I quickly changed my mind. Because we're going to do third, fourth, and fifth roots or whatever else, I think it's really a better idea to do the entire tree every time. Okay? So we're going to do the entire tree. So this could be 4 and 3. And obviously you could pick different numbers along the way. But once your tree is done, you should have all the same numbers circled. And remember, I think it's a good idea to circle when you're done with the branch and you get a prime number. That way you can clearly see what you're trying to use up there. Okay? We all good with that? Then, because it is a square root, because my index is 2, even though it's not there, I look for pairs. I look for 2's. So I have 2 2's. If I can cancel out 2 2's, that means it comes out as a single 2. This 2 does not have a pair, so he stays inside. This 3 does not have a pair, so he stays inside as well. Everybody with me so far? Then I look at so I've taken care of the 24. I've got x squared. I take the exponent, which is 2, and I divide it by the index, which is 2. 2 divided by 2 is 1. There's no remainder, so it just comes out as an x, because I have to divide that, because the square root of x squared is x, right? So then I'm done with that guy. Y to the 6th, I take the 6 divided by 3. There's no remainder, so y to the 3rd comes out. And I've taken care of everything inside of there. And if there's a ton, you might want to mark out as you go. Not a bad habit to get in. Then I just need to clean it up a teeny tiny bit. Outside stays 2x y cubed times I times the square root of 6. And that is my answer. That is simplified. If you need to check yourself, you square everything that's on the outside. 2 squared is 4 times 6 is 24. X squared is x squared. Y cubed squared is y to the 6th. And then I squared is -1. You can kind of see if it all fits back in there. That's one way to check yourself. Any questions at all? Okay. So let's move on to number 2. let's kind of go about the same process here. I'm having an equal sign. This is a cube root, so I got to pay attention to that 3. So I'm probably going to have something left in there. Hopefully I've left myself enough room. If not, we can make it work. If I am taking the cube root and I have a negative, will I end up with I? No. Think about it just being a negative 1 times 81. What's the cube root of negative 1? Negative 1, right? Because negative 1 times negative 1 times negative 1. So if you have a negative and you have an even root, it comes out as an I. If it is an odd root, it comes out as a negative. Okay? So I've taken care of the negative. Then I'm going to do the 81 and I'm going to do the tree, just like I did before. What are two numbers that multiply to give me 81? Oh, good. I was about to cry. Okay, 9 times 9. And then this gives me 3 and 3 and 3 and 3. Okay. Now, this is a cube root. My index is 3. So instead of looking for pairs, I'm looking for sets of 3. So now I mark out 3 3s, and I take it out, leave it in here, or leave it outside as one single 3. Then this guy, he's all by himself. He would need 2 more to be able to come out, so he stays inside as a 3. Okay, so the root's the same thing. That's why it's good to do the whole tree and not stop for shortcuts, because it won't work the same on every single thing you do. So then I look at x cubed. I take the exponent, divide it by the index. So 3 divided by 3 is 1. No remainder, so an x comes out. Then I look at y to the 6th. 6 divided by 3 is 2, so y squared comes out. Then I look at z. That exponent is 11. How many times does 3 go into 11? 3, with how much left over? 2. So this is what I do out here, which I didn't really leave myself a lot of room. But I'm a z, I said it goes in there 3 times, right? So this will be z cubed. And then the leftover z's stay inside. And then I wouldn't have to rewrite it, but that looks like junk, so I want to make sure you can read it. 3xy squared z cubed times the cube root of 3z squared. And again, if we check ourselves, but this time it was a cube root. So 3 times 3 is 9 times 3 is 27. 27 times 3 is 81, so I'm good. X squared is x squared. Y squared I'm sorry, not cubed. Oh, it's cubed, I'm doing it wrong. X cubed is x cubed. Y squared cubed is y to the 6th. Z cubed is z to the 9th. I add 2 more, that would be z to the 11th, and that's how I check myself. Okay? Everybody okay so far? Yes, sir.
Can you explain why there's no I in the...
Yes, because if I take the square root, right, so the square root of -1, we know that that is I, right? If I take the cube root of -1, that means I want, so basically this is what is the number times itself that would, if I'm going to square this, that would give me that back. So -1, if I multiply -1 times -1, that's 1, right? Times a -1. So these two multiply to give me 1 times another 1 is a -1, so I can take the cube root. And since there's an odd root, that's why you get to do that. Does that help? Okay. All good? Thank you for asking. All right, so now let's look at 3. Now there is no negative, but if that was -32, would I have I or would I have a negative? I, because it's an even root. Okay? Even root gives you I if it's negative. Odd root gives you the negative out. Okay? All right. So then we're going to kind of start the same way here. I'm going to leave myself maybe a little bit more room than I did on the last one. 4th root here. All right. So I don't have any negative to worry about. I'm going to take this 32. What are 2 numbers that multiply to give me 32? 16 and 2. Okay? 16, what would you do? 4 and 4. Okay? 2 and 2, and 2 and 2. I could have started with 4 and 8. I could have, and when I got to 16, I could have done 2 and 8. It doesn't matter. In the end, you should have 5 2s there. That's all that matters here. So this is the fourth root. So how many 2's do I have to look for? 4. 1, 2, 3, 4. When I find 4 of them, they get to come out as a single 2. This guy, and here's why I circle it. See him all up there? If you hadn't circled it, you might forget he was there. He's all lonesome. He has to stay inside. I'm done with the 32. Then I have x to the 10th. So I know something's going to come out because it's greater than 4. How many times does 4 go into 10? 2. With how much left over? 2. So then I have an x squared inside as well. Everybody okay with where the exponents are coming from? Then I look at y. Y to the 15th. So how many times does 4 go into 15? 3. So a 3 comes out here. With how many left over? 3. And by the way, those numbers won't always match. Just realized that was happening. And then z to the 8th. 8 divided by 4 is what? 2. And there's no leftovers, so all of the z's get to come out. And then I don't necessarily know that I need to rewrite that. It doesn't look bad. Everybody okay with all that? Now let's say when we did this, like I put my little fourth root there, and because I'm just assuming something's going to stay in, but if everything actually came out and I had nothing underneath there, I would not leave an empty root. I would basically just like erase it or mark it out, because it's basically just like the fourth root of 1 or whatever. There's nothing left in there. Okay. What questions do we have? All right, so this one's a little different because we have that 3x out front, right? So he basically already got to come out. We just can't forget about him. So we're going to do equals, and I'll start with this 3x. I'm going to leave myself some space for whatever else might come out, and then a square root. So I've already taken care of the 3x by rewriting it right there. So then I do 8. 8 is 2 and 4. I was going to write the wrong thing. And then 2 and 2. And now with square roots, if you are comfortable taking shortcuts, or you know that the square root of 8, or the square root of 8 is 2 square roots of 2, like it's fine. You don't have to always show that. But if you're going to do it, I would suggest the entire tree so you don't get things confused when you get to other roots. All right, so I'm going to have 2 2's. That gets to come out as a regular 2. And everything is being multiplied. There's no adding or subtracting anywhere. This guy has to stay inside. Then I have x to the 4th. What do I divide 4 by? 2, because it's a square root, and that'll give me x squared that gets to come out. And then y cubed, 3 divided by 2. Well, 2 goes into 3 once, right? With how much left over? 1. And then this one we do need to clean up some. I just need to multiply the 2 times the 3 and get 6. X times x squared is x cubed. And then times y times the square root of 2y. Okay. What questions do you have? So really, if you understand how to simplify square roots, and you understand what a 4th and 5th root is, you could take the 10th root of something if you had to. I mean, most of the time you're not asked to do that stuff by hand when it's that big, but it's the same principle. You just have to know what you're dividing by or whatnot. Any questions at all? All right, good deal. So now we have number 5, which I know we don't have a lot of room underneath it, but I was trying to space things out a little bit better, so we're going to kind of go sideways on this one. Can I take the square root of x squared and say this is equal to x plus the square root of 6x plus 3? Can I take the individual square roots like that? The answer to that is a big fat no. So you might want to write... I really don't understand why it acts like it's out of ink, because it's clearly picking something up. There we go. This is not equal to that. I was able to do the individual pieces on the other ones because they were being multiplied. When you add addition and subtraction in there, the rules change. Okay? It does not work that way. So it's not that. Let's talk about what it is. Well, I can't... since I can't just take the square roots of the pieces, what is something I could do with this right here? I could factor it. So if I factor that, and I get 2 binomials, I know this would be x and x. Would it be Plus, plus, minus, minus, or a mixture? Plus. This is positive, so the signs are the same. This is positive, so they're both plus. Then two numbers that multiply to give me 9 and add to give me 6. 3 and 3. Right? Then I can rewrite this as the square root of x plus 3 squared. Now can I take the square root? Yes, and I get x plus 3. What questions do you have? Now, let me just clarify this, because now that I'm looking at everything I wrote, you got x plus 3. Well, look, here's the x, here's the 3. Will that happen every time? Yes, if you have a perfect square trinomial. But it's possible you get something like this that you can't simplify. So the reason that that happened is because we actually were able to factor it like that. But if I change this term right here, then it doesn't work that way. So, okay, we all good with that? Are y'all even paying attention to me over there? I don't believe you. All right, any questions? Okay, so now we're going to talk about multiplying them. All things radicals today. We're going to multiply some. Now when I multiply square roots, everything that is outside the square root lives in one universe, and everything inside the square root lives in another universe. Okay? So I can multiply everything outside the square roots together. And again, no addition or subtraction, or my rules are different. But I can multiply 2 times 3. That's going to give me 6. And then square root of whatever 6 times 3 is, which is 18. Now, before we started, square root of 6 and square root of 3, we couldn't simplify either one of them. But we need to check to see if maybe now we can simplify the square root of 18. And I think we can. So if I do this, it gives me 2 and 9, right? And then 9 gives me 3 and 3. And then when I simplify this, I can't forget about this guy. He's already out there. That's 6 times. It's a square root, so 2 3s come out as a regular 3. This guy stays inside. And this is 18 square roots of 2. Okay. What question do you have? Anything? Okay. Now when I look at number 2, can I just multiply the 3 times the 3 and the square root times the square root? I've got a plus or minus in there, like this is addition and subtraction, so my rules are different. Now, this technically is a special case, but they won't always be a special case, and even if they are, you don't always recognize them as that. So we're going to first treat it like we don't even recognize it as a special case, because that's fine. When you multiply binomials together, you could have learned it multiple ways. You could have learned like the box method or distribution. Does the term FOIL mean anything to any of you? Yes? It's funny how that's how I learned it. And then when I started teaching, there was all these tricks of the trade, and they would change every few years, and we're kind of just back to FOIL. Like, really, that's just fine. That stands for first, outside, inside, last. So we're going to multiply the first two together, 3 times 3, and get 9. Then we multiply the outside 2 together, and that gives me a negative 3 times the square root of 6. Because all you can do is stick them together. Then the inside 2 together, which will give me a positive 3 square roots of 6. And then the last 2 together, first of all, this is negative, right? Because positive times negative is negative. And what's the square root of 6 times the square root of 6? 6. It's just 6. When you multiply 2 square roots that are the same together, or you square them, you get what's underneath it. Okay? So I used to have signs on the board that said like a square root of a monkey times the square root of a monkey is a monkey. It doesn't matter what it is, you get what's underneath the square root. Then we can clean this up. These zero out, and I end up with 9 minus 6, which is 3. Now, does anybody recognize that as a special case? And if you do, what it's called? Because sometimes I know you don't know the words. That is a difference of squares. But again, we don't always recognize it as that, and that really wasn't that bad. But I'm not going to point that out. I'm trying to decide. Maybe, maybe not. Maybe it's better if I don't. Maybe if I wait till later. All right. Any questions on that? We good with FOIL? Because, I mean, we should be able to FOIL if it's x plus 3 times x minus 2 or whatever also. So now we have this square root, or this mixed square root, squared. This, I'm going to tell you right now, I get some weird answers on, and a lot of times the weird answers come up because people try to do it on the calculator, and the majority of the people that are trying to do it on the calculator get it wrong, but think it's right because it's the calculator. But the calculator is only as accurate as what you type in. So instead, this squared gets distributed to both of these. Again, if there was addition, totally different rules. But this is the same thing as 2 squared times the square root of 5 squared. What's 2 squared? 4. What's the square root of 5 squared? 5, because it's just 5. And then, so that's 4 times 5, and that gives me 20. Okay. Everybody okay with that? Any questions at all? Okay. Then let's look at number 4. So on number 4, I have square roots that I'm squaring also, but I have subtraction there. So let's just write this down. This does not equal 3 squared minus the square root of 6 squared. That is what not to do. You don't get to distribute it there. You can here. You cannot do it there. All right, instead, I want to rewrite this as 3 minus the square root of 6 times 3 minus the square root of 6. That's what squaring something means, right? Is that you multiply it by itself. Does that make sense to you, how I just rewrote that? Yes, basically. Yes, I mean, here you could have rewritten it, like we could have written 2 square roots of 5 times 2 square roots of 5 instead. Like that's fine because that's still squaring it, and you would still get 4 times 5, and that would work as well. But you don't have to. You can distribute it here. You cannot distribute it there, and you have to do that. Does that help? Okay, then we FOIL. We multiply the first 2 together. 3 times 3 is 9. We multiply the outside 2 together. That's going to give me negative 3 square roots of 6. We multiply the inside together. That's going to give me another negative 3 square roots of 6. Then the last 2, and that's negative times negative, which is positive. And square root of 6 times the square root of 6 is 6. So then when I clean this up, the 9 and the 6 I can add together, so that's 15. And then negative 3 square roots of 6 and negative 2, that's going to be negative 6 square root of 6. And that's the best I can do. So if you look at the difference between these two, this one was even the same numbers, but this had a plus and a minus where I ended up with 2 minuses there, and it just, it changes the whole thing basically. Any questions at all? All right. So then we have this one. This one is not a special case. This one is not a difference of squares. That's why I was like, do I talk about it on that one or do I not? Because these don't actually like all match up. But I can still multiply them. I just couldn't. It's not a special case. Here I'm going to have to FOIL. So I'm going to multiply the first 2 together. 2 times 3 is 6. So first, outside. So that's going to be a negative 2 square root of 3. Inside, positive 3 square root of 8. Last 2. First of all, that's negative, and it'd be negative square root of 24. And then as it stands right now, I cannot combine like terms because I don't have like terms. I can't do anything with this guy. I can't do anything with that guy. This, I'm pretty sure I can simplify, right? So I'm going to see what I can do here to simplify this. Do y'all have room down there? You might have to go off to the right of it. Because I can keep scrolling down, but you might have to use the space to the right of it. So this is 2 times 4, and then 2 times 2. So I'm going to rewrite. I'm going to start by rewriting 6 minus 2 square roots of 3. And then this right here, these 2 2's come out as a regular 2. So that's going to be 2 times 3, which is going to be a positive 6. This guy stays underneath, square root of 2. Everybody okay where everything came from? Then I'm going to try to simplify this guy. I can do 4 and 6. This is 2 and 2. This is 2 and 3. So this is minus. These two 2's come out as a regular 2. Both of these things have to stay inside and get multiplied back together, so that's 2 square root of 6. And I still don't have like terms. This is like 6 minus x, y, and then z there because they're completely different. Okay. What questions do you have? Anything? Okie dokie. So then we're going to add and subtract radicals, which we kind of already did a little bit, but here are the rules. So remember that this is where your index is. So two radical expressions, so that's what this is. These are two radical expressions, are like radical expressions if the indices must be the same and the radicands must be the same. So the index being 2, 3, 4, whatever, those are the same here because these are both square roots, so A works. But the radicand, what's inside, they do not match. So here the answer is no, we cannot do that. Square root of 2 plus the square root of 3 is just square root of 2 plus the square root of 3. That's all we can do. When I look at number 2, the radicands are the same, but the indices are different, right? So can I combine those? I cannot, so this right here is a no also. Here, these are all 3 square roots, so that's good. They all 3 have the square root of 2. That's good. When you're adding them, think about them as variables. And y'all been talking about variables literally since kindergarten. Because your teacher would be, okay, I have 2 teddy bears. If I get 3 more teddy bears, how many do I have? I have 5 teddy bears, right? And your teddy bear was your variable. So this is like 3 teddy bears plus 4 teddy bears plus 1 more. Or 3x plus 4x plus x. How many do you have? 7, 8, right? 3 square roots of 2, 4 square roots of 2, that's 7, and add 1 more, this is just 8 square root of 2. So this is a yes, and that's what we get. You with me on that? They are just things. Look at them as variables. That's why if they're different, like this is basically x plus y. And then this is 3x plus 4x plus x, and that's where you get that from. Okay, so don't try to make it harder just because there's square roots there. All right, so on 4, when I first look at it, like, well, they're both square roots, but these things are different, so I'm going to put a no with a question mark because I'm pretty sure I can simplify those. So maybe after I simplify them, then I can, but right now, as it stands, I can't. So then we're going to simplify. 8, it becomes 2 and 4, and then this is 2 and 2. So if earlier you were thinking, there's no way I'm ever going to know that the square root of 8 is just 2 square roots of 2. Well, you do it enough times on one worksheet, you're going to know it, at least for a little while. So you might not even have to do all that. So this is going to become 2 square roots of 2, right? Once I cancel all that out. And then this 18 will become 2 times 9. And then this would be 3 and 3. So then this is plus. Now, these 2 3's come out as a regular 3, but they also have to be multiplied by this 2, so that gives me 6 square root of 2. So can I combine these? Yes. So this is actually yes. And my final answer is 8 square roots of 2. What questions do you have? Anything? All right, so 5, as it stands now, again would be a no with a question mark on it. But I can simplify this, right? 3 and 9. 9 becomes 3 and 3. So then I'm going to rewrite everything. I'm going to start with this 3. 3 plus, and then 2 3's come out as a 3. This guy stays inside. Then make sure you distribute this negative, because then that becomes minus 2 and then plus square root of 3. Which means when I simplify it, and I guess I'll write it right there, I can do the 3 minus 2, which is 1. And then what's 3 square roots of 3 plus the square root of 3? How many square roots of 3 do you have? I have 3 here and 1 here. That's a total of 4 square roots of 3. And that is my answer. What questions do you have? Okay. One more, and then we'll get to imaginary numbers tomorrow. So again, as it stands here, which really this turned into a yes. As it stands here, exactly like it looks is no, but I think I can simplify some things, right? The square root of, so 6 is really just 2 and 3. Is there anything that can come out from the 6? It can't, right? It's got to stand there. But x to the 5th, if I divide 5 by 2, how many times does 2 go into 5? 2, so this becomes x squared out here. The 6 is still under there, and how many x's are left inside? 1, because it was the remainder, yes. Everybody good with that? Then I'm going to do the second part. So actually over here, the x has to stay inside, right? So I'll come over here and do the 150. And so I'm going to start with 15 and 10. Then that's 3 and 5. And that's 2 and 5. So then this is plus 7x squared times, well, I have the 3 has to stay inside because there's no pairs. I do have 2 5s, so that can come out. There's only 1 2, so it stays inside. And remember, everything gets multiplied when you're doing that. So then to clean this up, oh, and I can't forget about this guy who was under there. Just left him out. So then I'm going to rewrite 10x squared times the square root of 6x plus 35x squared times the square root of 6x. So in this case, not only do my radicands have to match, which they do now, they're both 6x, but because there's variables outside, those have to match too, right? Just like anything else with variables. So I'm good with that. So I have, basically if you look at it like this, like I have 10 of these things, and I'm going to add it to 35 more of those things. So how many of those things do I have? 45. So 45x squared is the square root of 6x. Okay. What questions do you have? All right. So I'm going to go ahead and give you your assignment. Oh, well, this works out well, because I was going to have to add the I part later anyway, because it's actually not on this assignment. So we'll talk about this tomorrow, but really you have all the skills you need to be able to handle what is on here.